Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 7 of chapter 4 from Engineering Mechanics Statics 9th edition by J.L. Meriam, L.J. Craig, and J.N. Bolton. Statement of the problem is determine the forces in each member of the loaded truck. You need to find member forces each member. So as member force in each member is required, so the method used to solve this problem is method of joints. In this video tutorial, I'm also going to explain how to use Casio FX991EX to solve simultaneous equation. Steps to find member forces using method of joints are: the first is select a joint with at least one unknown force, load or reaction, and two or less than two unknown member forces and or support reaction. So at joint A, there's one load applied, which is 3000 pounds. So one load is known at joint A, and two member forces A, B, and AE are unknown. So I can start with joint A. So to start with, need to isolate the joint and draw a free body diagram by assuming all member forces in tension, arrow away from the joint. Then need to apply sigma fx equal to 0 and sigma fy equal to 0, but before need to resolve inclined member into their components. Free body diagram of joint A is drawn. So 3000 is one known and AB and A are two unknown, and AB is making an angle theta with horizontal. So AB can be calculated using triangle ABE, and in triangle ABE, so that is angle theta. So it can be calculated as tan theta is equal to opposite over adjacent. So 2.5 over 4. So theta can be calculated as tan inverse 2.5 over 4. So theta AB, which makes it horizontal, is 32 degrees. So joint A, AB is resolved into its component ABX and ABY. So AB, when you rotate it towards nearest horizontal, so the nearest horizontal is positive x-axis and the nearest vertical is positive y-axis. So its two components are shown there. So the next one, to apply sigma fx equal to 0 or sigma fy equal to 0. So as there is only one unknown in vertical direction, so it is better to first use sigma fy equal to 0. So applying sigma fy equal to 0, so ABY is positive and then 3000 pounds is negative. So ABY is equal to 3000. ABY is equal to AB sine 32, and then AB is 3000 divided by sine 32. So answer is plus 5661.24 pounds. Then once AB is calculated, so then applying sigma fx equal to 0, so that is AE is positive and ABX is also positive. So AB is equal to minus ABX, and ABX is AB cos 32. So by substituting the value of AB in here and simplifying it, so AE is minus 4801. So once member forces are calculated, then interpretation of sign. So a positive value indicate tension and a negative value indicate compression. So AB is positive, so then 5661.24 pound in tension, and AE is negative, so that is 4801 pounds in compression. So that is member forces at joint A. Member forces at joint A are calculated. So next is repeat step 1 to step 3 for adjacent joint that has two or less than two unknown. So for joint A, adjacent joints are B and E. E joint that has two unknowns and joint B that has three unknowns. So I'm going to select joint E. So joint E, it can be solved by just inspection. Using the rule about three-member joint with load parallel to a member. So joint E is a three-member joint and a load is acting parallel to a member. So in a three-member joint where two members are collinear, so here in joint E, A, E and D, E are collinear and a joint load acts parallel to non-collinear member. So joint load 4500 is acting parallel to BE. The non-collinear member carries a force equal in magnitude to the load but in opposite sense. So magnitude of member force BE is 4500 but that is in opposite sense. So here at joint E it is acting vertically downward, so then BE must act vertically upward, so that is in tension. The two collinear member carry force equal in magnitude. So AE and DE that have forces equal in magnitude. So DE is 4801 and have same sense. Means both in tension or both in compression. So AE is in compression, so DE must be in compression. So that is a rule. So joint E can be solved just by inspection. So joint E is analyzed to just check about this rule. So at joint E, so that is a free body diagram of joint E. 4500 pound is acting vertically downward. AE is in compression. So I have assumed DE and BE both in tension. So apply sigma fx equal to 0. So DE plus AE is equal to 0. So DE is equal to minus AE. So which is minus 4801 because AE is already calculated as 4801 and apply sigma fx Fy equal to 0, sigma Fy equal to 0 is BE minus 4500 is equal to 0. So BE is equal to 4500. Now DE is negative. So negative mean that DE is in compression and BE is positive. So that means it is in tension. So AE and DE are collinear members at joint A, E, so they have member force is equal in magnitude and in the same sense. And at joint E, non-collinear member, which is parallel to the load, so magnitude of member force in a non-collinear member BE is equal to the load, and that is in opposite sense. So now joint E is solved using conditions of equilibrium, or otherwise it can be solved using the rule which I explained. So now joint answers of member forces at joint E are DE and BE. So now after joint E, next adjacent joint is B and D. At B there are two unknown member forces and at D there are also two unknown member forces, but D is a roller sport, so it has an unknown reaction as well. So I'm going to now analyze joint B. So need to isolate the joint and draw a free body diagram. Free body diagram of joint B is drawn. So BC and BD both are inclined member and AB is known. That is also an inclined member. So AB, now if I'm going to draw a horizontal line here, so that angle is also theta. So I need to find angle BD which makes with horizontal. So let's say I'm going to call it as phi, and then BC makes with horizontal. Let's say I'm going to call it psi. So it is possible. So if I draw a perpendicular line from B on CD at a point B prime, So then B prime D is now 2.5 inches of feet, and then total CD is 3.5, so CB dash is then 1 foot. So now I can find psi using triangle CBB dash and phi using triangle DBB dash. So in triangle CBEB dash, so tan phi is equal to opposite over adjacent. So BB dash is equal to 6 foot. So then I can phi is 9.46 degrees. And in triangle DBB dash, so tan phi is equal to opposite 2.5 over adjacent is 6 feet. So then tan phi is equal to 2.5 over 6. So phi is 22.62 degrees. So that is free body diagram of joint B with inclined member resolved into components. So BC is resolved into BCY and BCX. BD is resolved into BDX and BDY, and AB is resolved into ABX and ABY. Whereas that BE is a vertical load of 4500, and then angles theta, psi, and phi, they are shown here. BC makes an angle theta with horizontal, phi 22.62 with horizontal, and AB as theta. So now there are two unknowns in horizontal direction and there are two unknowns in vertical direction. So either sigma fx equal to 0 or sigma fy equal to 0 can be applied. So applying sigma fx equal to 0, so bcx is positive, bdx is positive, and abx is negative. Since bcx plus bdx minus abx equal to 0, so bcx is bc cosine psi, bdx is bd cosine phi, and abx is ab cosine theta. And then substituting the value of psi, phi, and theta, and value of AB, so it is, and then rearranging that, it become cos 9.46 BC plus cos 22.62 BD is equal to 5661.24 cos 32. So this is equation 1. Now applying sigma fy equal to 0. For sigma fy equal to 0, BC is acting vertically upward, so that is positive. Then BD is negative, ABY is negative, and B is also negative. So it is BCY minus BDY minus ABY minus DE is equal to 0. So it is rearranged as BCY is BC sine phi psi, BDY is BD sine phi, and AB and Y and DE, by taking on the other side, it will become DE plus AB sine theta. So now substituting the value of psi, phi, DE, AB sine theta, and then after rearranging, it is sine 9.46 BC minus sine 22.62 BD is equal to 4500 plus 5661.24 sine 32. That is equation 2. So now I have two equation 1 and 2. They are the simultaneous equation because both equations contain B, C, B, D. So I'm going to solve these equation using calculator. So I have here Casio FX 991EX. So to solve simultaneous equation, menu, and then in menu there is equation and function. So it comes with A. So press alpha A. So now the first option is for simultaneous equation. Click 1, and then simultaneous equation number of unknowns are 2. So press 2. So now this is a system of equation which contain two equation. So BC in both equation is written as first. So the calculator is going to assume that BC as X, and then BD is a second. So calculator is going to assume BD as Y. So then in the first equation, it is cos cosine 9.46. Then press equal, then cosine 22.62. So that is the coefficient of y, which is BD here, and then 5661.24 times cosine 32. So that is the first equation, enter there. Now the second equation is sine 9.46 BC minus sine 22.62 BD is equal to 4500 plus 5661.24 sine 32. So it is sine, then 9.46, and then minus sine 22.62 equal 4500 plus 5661.24 into sine 32. So both of equations are entered in the calculator. So now by pressing equal, so that is the first value of BC, that is 16,512.094. So BC is plus 16,512, and now Y is minus 12,443.759. So it is rounded as 8. So now BC and BD are calculated use with calculator. Now the answer of BC is positive, so BC is in tension, and answer of BD is negative, so BD is in compression. So that is solution for the member forces at joint B. So after solving joint B, then adjacent joint is either C and D. At D, there is one member force, and as a roller sport, there is one reaction. C is a pin sport, so pin sport has two reactions and one member force. So at D, there are two unknowns, and at C, there are three unknowns. So I am going to now select D and going to draw its free body diagram. So now at joint D, the only member force left is CD, and then I'm going to assume reaction towards right. And DE is in compression and BD is also in compression. So the angle which BD makes with horizontal, so which is shown here, is psi, because both of these angles are alternative angles. So now I'm going to analyze joint D. So now joint D, inclined member is BD, so it is being resolved into BDX and BDY, and then only unknown member force is CD in vertical direction. So I'm going to apply sigma Fy equal to 0. So CD is plus and BD is minus. So CD minus BDY is equal to 0. So CD is equal to BD sine phi. So now I have BD as 12,444, and I'm going to use that more precise value into sine 22.62. So after simplifying, CD comes as 4786.1, and because CD is positive, so CD is in tension. It is the only member force at joint D. So now whole problem is solved. So the member forces with their value are shown on the truss, and these are the answer at the back of the book. AB is equal to 5660. So by rounding up to three significant figure, it is 5660. And then AE and DE are equal, and again by rounding to three significant figure, it is 4800. BC, rounding to fourth significant figure, it is 16,510. Similarly, BD is 12,440. BE is 4500 here, and then CD is 4790 by rounding to three significant figures. So that is complete solution of problem 7 from chapter 4. Thank you very much.